Hi everyone, in today's lesson we're looking at logarithms and change of base. So we have a warm-up problem here. This is an IB problem pulled directly from some of the practice they've provided our school. In a plentiful springtime, a population of 1,000 mice will double every week. The population is given by the function 1,000 times 2 to the t mice. Things to think about. What does the graph of the population over time look like? All right, so first of all, we'll do a table of values. I'll keep this really short and sweet. And I'm just going to put some really easy values in. The time in weeks wouldn't be less than 0, starting at 0 at the beginning and maybe doing the first and second weeks and seeing what that graph looks like. If we put 0 into that function, we get 1,000. If we put 1, we're going to get 2,000. And if we put 2 in, we're going to get 4,000. We're going to just do a very rough sketch of the graph, not to scale. All right, so we plotted our points and we're looking at our graph. This is the answer to letter A, what the graph looks like over time. And then part B says, how long will it take for the population to reach 20,000 mice? So we want to know, when is the output value of this function going to be equal to 20,000? So we're going to do 20,000. Now you could certainly try to do this in your graphing calculator, but I just feel like algebraically this particular problem is easier. If we divide 20,000 by 1,000, we're going to get 20 equals 2t, 2 to the t power. And because we have a variable as an exponent, we know that we're going to use a logarithm because one of the laws of logarithms is the power rule, which will allow us to bring that t out front. So we're going to take the log of both sides at this point. I'm going to take the log base 2 of both sides. And the reason that I took the log base 2 of both sides, because I know that the log base 2 of 2 is 1. I mean, that's true of any time we have the same base and this part is the same. If we had log base 10 of 10, that's 1. If I had log base 25 of 25, that's 1. So log base 2 of 2 is 1. So what does that mean? That means we have log base 2 of 20 equals t. And then we can just put log base 2 of 20 in our calculator. So we'll go to our calculator. We're going to go to math. And we're going to scroll down and we're going to look for the log function. All right, we're going to pick log base. We're going to type a 2, 20, and we get 4.32. So let's write that in. T is approximately 4.32 weeks. Now we did use our calculator for that. You may not have the latest model of the calculator. If you don't, you can just use change of base instead of using that function that I just showed you. So to use change of base, as a reminder, you would type log of 20 and then log of 2. And you would get the same, you can produce the same result that way. So that's just a reminder on that. So we have logarithms in base 10. Consider the graph of y equals 10 to the x. The logarithm in base 10 of a positive number is the power that 10 must be raised to in order to obtain that number. If no base is indicated, we are going to assume that the base is 10. This is just a reminder about logarithms. Right, so we did already do some, revisiting of logs and properties of logs. I'm just reminding you again, if we just write something like log 9 equals x, we assume that there is a 10 here. All right, if no base is written, we assume it's a 10. Now, this next part is just, again, demonstrating to you how to take a log and put it in exponential form. So let me write that over here. We have log base A of B equals x. To put that in exponential form, it's a to the x equals b, right? We have our base, we have our answer, and we have our exponent, right? And sometimes I use the little acronym bacon and eggs, just to help you remember. So we have our base, answer, exponent, bacon, and eggs. Or you can just use the arrow. A to the x, another arrow to the b. So in exponential form, this would be a to the x equals b, as I show you here. Now, I just want to remind you something. I'm going to pause here for a second. In the beginning of the school year, you may or may not remember that I have pointed out to you that this course has a formula booklet. You should have printed it off and you should be using that as a reference. You're going to be able to use that formula booklet when you take the IB exam. So let me open up the formula booklet. It looks like this, okay? Gives you all the topics. We're dealing with topic 1, numbers and algebra. So we're going to scroll there. And you can see right in the booklet, okay, we've got, how to convert from exponential form to logarithmic form. And we have all the properties, including change of base. Everything is right here. You don't have to memorize any of this. Okay, so here are our laws of logarithms. When we're adding logs, it's multiplication. When we're subtracting, it's division. And then we have the power rule that if we have a value here, we can bring it out front. Or if it's in the front, we can bring it up and make it the exponent. We're also being reminded that the natural log base e, can be written with shorthand as ln. We also have a button on the calculator for ln. So we have the log button that I showed you already, and we have the ln button right below it, highlighted in red. Okay. Some more properties, ln of e. Well, ln of e is just 1. Why is that? Because log base e of e is 1. Just like log base 2 of 2 is 1, or log base 100 of 100 is 1. Log base e of e is 1. ln of e is equal to 1. All right, so we have ln of e to the x is equal to x, and another one, e to the ln of x is equal to x. Now, all the laws that apply to a regular log with a base of 10 or something else is also going to apply when we talk about logs base e. All the same rules apply. So if we are adding natural logs, we would combine using multiplication. If we're subtracting natural logs, we would combine using division, right? And the power rule, if we have an exponent, we can bring it out front, or if it's out front, we can make it the exponent. The change of base rule I showed you on the calculator just a few minutes ago, but if I'll do another example, if you have log base 2 of 3, you could put that in your calculator just like that, or you could put it in your calculator as log of 3 divided by log of 2. Just make sure you use parentheses. All right, so we have some practice, and notice it's saying simplify numbers 1 to 5, but do not use a calculator. All right, so we want to try to rewrite these to make it easy on ourselves, and it's really just testing that you're understanding and using some of those laws and properties that we just looked at. All right, well, I'm going to rewrite log of 100 as log base 10 of 10 squared. So that's this part, right? Because log base 10 of 10 is 1. Log base 10 of 10 to the 4th is the same as log of 10,000, all right? So The log base 10 of 10 is just 1 for both of these, and because of the power rule, I can bring the 2 out front and the 4 out front. So what do we end up here? We end up with 2 plus 4, which is going to give us 6. All right, you should try to do the rest of these on your own and see how you do. All right, I'm going to do log base 5 of 5 squared. 5 squared is 25, so that's this part. And then I'm going to do log base 5 of 5 cubed, because 5 cubed is 125. Then using that power rule, the 2 can come in front, the 3 can come in front. Log base 5 of 5 is just 1. So we end up with 2 plus 3 equals 5. These are kind of fun. I hope you think so. And we have log base 5 of 5 cubed. 5 cubed is 125 minus log base 5 of 5 squared. All right. So we end up with 3 minus 2 equals 1. We've got log base 5. Ooh, this is kind of sneaky. 5 squared squared. Okay. There's a couple ways we could look at this. So that would be equal to log base 5 of 5 to the 4th, and then I could bring that 4 out front, so this one is equal to 4. Now another way I could do that, let's look at another way I could do that. I could say, well, I've got log base 5 of 25, but that 2 can come out front. And then I've got 2 times log base 5 of 5 squared. That's the same as, that 2 now can jump in front. So that's the same as 2 times 2. And that way, we also equal 4. I think the first way that I did it was easier, but you could think of it the second way as well. Okay, now looking at this last guy, I'm going to say that I have 2 times log base 5 of 5 squared. This 2 will come to the front. Log base 5 of 5 is 1. So we're going to end up with 2 times 2, which equals 4. Number 6 says approximate the following logs using some information. Now, you would have your calculator. You would just be able to put in log base 5 of 2, but this is saying try to do this without using your calculator. See if you could find a way to write log base 5 of 2 as log base 5 of 3 and log base 5 of 6. Okay, so let's see here. If I say that I have log base 5 of 6 divided by 3. Okay, so far I haven't, it's exactly the same thing. Instead of writing 2, I wrote 6 divided by 3. Now if I expand that, I could say log base 5 of 6 minus log base 5 of 3. Right, you see how this is getting you to really think about the properties. When I have division and I expand it, I'm going to have subtraction between. And we're not using our calculator. So log base 5 of 6, we were told was 1.113. Log base 5 of 3, we were told is 0.683. And if we do that, we are going to end up with 0.43. Okay, now we've got log base 5 of 18. Well, log base 5 of 18. 6 times 3 is 18. If I'm trying to expand a log and I have multiplication between, when I expand it, it's going to be addition. So this is going to be log base 5 of 6 plus log base 5 of 3. I'm not allowed to use my calculator. I know that log base 5 of 6 is 1.113. Log base 5 of 3 is 0.683. When I add those together, I get 1.796. Okay? Number 7, you're being asked to expand the log. When we expand a log, we are making the log sentence as long as we possibly can make it, right? And this is another exercise to get into your brain how we use the properties of logs. So when we have division and we're going to expand it, it's going to be subtraction. So this is going to start out with log base 4 x squared minus log base 4 3y cubed. Okay, now we can take that 2 and we can put it out front. So we're going to put 2 log base 4 of x minus. Now we have multiplication between these two. When we expand and we have multiplication, it's going to be addition. So we're going to have log base 4 of 3 plus log base 4 of y cubed. Okay, and we're still not quite done because this 3 can still come out front. We can make this sentence even longer. And I think I'll distribute that negative as well. So we're going to end up with 2 log 4x minus log 4 3. Then we have a negative times a positive, so we're going to have a negative. We're going to take that 3 and we're going to put it out front. So it's going to be 3 log 4y. So that's as long as I can make that log sentence. It's fully expanded. Now, number 8 says condense. I'm just going to erase that. When we condense a log, we're going to make sure that our final step only is using the word log once, right? So let's see what we can do here. Well, first off, I'm noticing that this 3 can just jump back up and be the exponent for the 2. So let's do that first. So we have log of 3 plus log 2 cubed minus log 6. And then I have addition between the first two. To condense them, it's going to become multiplication between those first two. So we're going to have log of 3 times 2 cubed minus log 6. And when we have subtraction between, that's going to be division when we condense the log. And if we do 3 times 2 cubed, that gives us 24, divided by 6, that gives us 4. So our final answer here is log 4. Number 9 is really a challenge problem. You should try to do that on your own, and when you're ready, restart the video. All right, so I'm going to recognize that we're going to have division here, and I'm also going to bring that 1/2 up and make it the exponent for 1 over 25. Okay, that gives us log base 6 of 3, and I can bring that 2 up. 1 over 25 raised to the 1/2 power, which is just the square root of 1 over 25. The square root of 1 is 1, the square root of 25 is 5. Right now we have addition, so that's going to be multiplication when we condense. So our final answer here is going to be log base 6 of 9/5. We're going to use change of base formula to evaluate log base 5 of 6. So it says to use common log, so we want to use log base 10. We didn't write the base, so we know we're writing in log base 10. And if we want to write that as a natural log, we would use log base e. Shorthand for that is ln of 6 over ln of 5. So these all mean the same things. We can put any of these into our calculator and we'll get the same value. Let me show you. All right, so we're going to go to math and we're going to use that feature of our calculator to start. And we're going to enter in log base 5 of 6. All right, now we could also put in log base 10 of 6 divided by log base 10 of 5. We'll get the same answer. Or we could use ln of 6 divided by ln of 5, and we'll get the same answer. So we're saying with change of base, we could use any base we want and do it log of that base of 6 divided by log of that base of 5. They're all the same thing. And so no matter which way you look at it, you get approximately 1.11. All right, now these are the fun ones. True or false? Use the properties of logarithms to determine whether the equation is true or false. If false, state why. So we want to kind of see if we could rewrite one side to make it look like the other side. So for letter A, I am noticing that I could rewrite log base 2 as 2 squared plus log base 2 of x, right? I haven't changed anything. I've expanded it a little. I'm just trying to see, if I can make it look like the right side. Well, this part here is 1. Log base 2 of 2 is 1, and that 2 would come out front. So if I continue to simplify that, we get 2 plus log base 2 of x definitely does not equal 2 log base 2 of x. So this guy is false. All right, so you get the idea. I would definitely suggest pause the video. It's going to hurt a little bit, but pause the video and try to do these on your own. And when you're ready, come back and see how you did. All right, for letter B, the only thing I can see I could do here is I could bring that 2x to the front. And then log base 10, right? We assume there's a 10 there because nothing's written. Log base 10 of 10 is 1. That just leaves me with 2x on the left. And that does equal the 2x on the right. And that's true. Okay? Let's see. For letter C, I could write log base 4 of 16 minus log base 4 of x. Let's say that's log base 4 of 4 squared minus log base 4 of x. Log base 4 of 4 is 1. Bring the 2 out front. I get 2 minus log base 4 of x. That does equal what's on the right side. Okay, moving on to letter D. I have multiplication between in the numerator and the denominator, so I'm going to rewrite that as ln of 5 plus ln of x. I have ln of 10 plus ln of x. There's really nothing else that I can see that I could do with that. That definitely does not equal ln of 1/2, so this one is false. Right? One of the properties we looked at above said that if we have e raised to the ln, whatever value is right here is what it's equal to. If you don't know what I'm talking about, go back to your notes, the beginning of these notes, and look at that. T equals t, so this is true. And then the last one, I think I could bring the 6 up here and the 6 up here to start. There's addition between, so when I combine them, it would be multiplication. And that could be rewritten as ln of x, y to the 6th power. That does equal what's on my right side. So this last one is true. Okay, that's everything in this lesson. Thanks for watching.